Okay. In the last class, so far in the module 2, we have seen the logic link control layers. That is the very first techniques we have seen is the error detection techniques. Then we have introduced the few sequencing modeling for the ARQ protocols. Then we have studied the three different ARQ protocols. The very first one is stop and wait protocol. The second one is go back in protocols, and third one was selective repeat protocols. So in today's class, we will study the framing function, especially the HDLC. Okay, so the HDLC, the full form is high level data link control. So whatever the ARQ protocols we have studied, so how these protocols, especially the go back and selective repeat protocol in real time, how the implementation will be taking place and how exactly these protocols will get activated. So those kind of situations we will be seeing at the end of today's class, right? So the high level data link control. So it is a bit oriented protocol. Bit oriented protocol means information will be in terms of bits. For example, 0101 or 1100. So in terms of this will be there, especially for communication. So high level data link control, it's a bit oriented protocol, means we can represent the information in terms of zeros and ones for communication. And here in the high level data link control protocol, here there are two types of links exists, right? This for communication, there are two types. So one is the point to point, and the second one is the multi-point links, right? So as I said, it's used for communication over, you can write here, over point to point and multi-point links, right? So it implemented the ARQ mechanisms, actually this HDLC protocol. Yeah. And the HDLC protocol provides two common transfer modes. So as I mentioned in the above statement, the above line, this is a bit oriented protocol for the communication over point to point and multi-point links, right? So in order to achieve this, so there are two different types of transfer modes. Means how these bits are the frames will be transferred from source to the destinations, right? So for that we have two different modes, and these are the very first one is normal response node. In short, we can write it as a NRM. And the second one is asynchronous balanced mode. We can write it as a ABM. Right? So these two transfer modes will be used in different configurations. Fine. So we'll see the very first one, that is the normal response mode, NRM. Right. So in NRM, so here I won't say the device or the uh, device or the nodes. Here, instead of device or node, I will be specifying them as a station, right? So here the station configuration is unbalanced. I will tell you why the station configurations are unbalanced. Here, the station means the communicating stations. Yeah, in specific, I can write communicating station. Communicating stations configuration is unbalanced, right? And here, actually, there are stations. Stations are there. The first one we call the primary station, and second one we call the secondary station. What is the role of the primary stations? The primary stations role is to sorry, so whatever the information it needs and whatever the functions the secondary station has to do, so those information will be sent by the primary stations by sending the commands. And the secondary station, sorry, secondary stations, what it does is, depending upon the commands given by the primary stations, they only responds. Right? The secondary stations only responds depending upon the commands which is given by the primary stations. And this the NRM, the normal response mode, it is used for both. Here in the above I have said, right? So it will be used for the HDLC, it is used for point to point and the multi-point links. Similarly, as this is normal response mode is the one of the transfer mode of the HDLC protocol, it is used for both point to point P2P and multi point MP. Right? So let's see with respect to the one picture or pictorial way. So this is the one station I'm having, and this is the another station I'm having. Right? And this I'm calling as the primary station. This is the primary station. And the second station, I'm calling it as a secondary station. Right? So first we'll see the point to point. Point to point. I'll make it bold so that it will be visible. Right? First we will see in the point to point links. Right? So this is the primary station and this is the secondary stations, and both has to interact with each other. So I'll be having the communication link like this. Right? And as I'm saying, it's a normal response mode. So the primary station's job is to send only the commands. Only the commands it will be sending. Right? Only the commands. And the secondary station's job is to reply to those commands. That is the response. Right? So it's a response. It will just send the only the response. right? This is for the point to point, means from one device to only the other device, only one device. So we cannot connect the multiple devices here. That's the reason we are calling it as the point to point link. And we are having the second one, multi-point MP, right? Multi-point link. So we will be having the same kind of a setup here also, same to same, but here instead of one secondary stations, we'll be having the multiple number of secondary stations. And these multiple of secondary stations, right? Even these also will send the same the response. So it will be connected in this manner. So this is not good. So I'll connect this to here. Right? So this is the secondary stations. So like this, many number of stations we can connect to the link. So here what is happening is it's a half duplex, correct? Half duplex. So the primary station has to send the information, then secondary stations will send back. Right? So here another again what we can say it's a unicast in both the side, but here multicast from the command from the primary station, but unicast from the secondary station. Got it? Okay, fine. So the this is done. Now we'll see the second one, the asynchronous. Asynchronous balanced mode. See here, I have at the beginning I said that uh, the normal response mode configuration is unbalanced, right? Because the primary stations cannot send the response, only it can send the commands. And similarly, secondary station cannot send the commands. It can send only the response. So this is a completely unbalanced. For balanced means, so both the functions, for example, the commands and the response of primary stations can send. Similarly, the secondary stations also sends the commands and the response, then those kind of setup or the system we call the balanced transfer mode of the information, right? So here in the asynchronous mode, the same setup will be there, whatever just I have explained. So the configuration is balanced here, means both the stations, primary and the secondary stations, can send the information like commands and the response. But here there will be no there will be no, like primary and the secondary stations. This concept won't be there. It's just a station here because both the functions can carry down by the stations, right? And the second point important is the link is peer to peer here, right? And each stations, which I have just now I have explained, each station function has primary and secondary station as this secondary. Correct? Let's see one example here. I'll copy this one. For me, it requires. Okay. So this is the setup for the asynchronous. So as I said, there will be no primary and the secondary concept here, right? And here The stations can send commands as well as response. And similarly, here, this station also can send the commands and response, right? So this kind of setup we usually see in the full duplex, right? So whatever uh, we will be having the conversation over the phone, that is a full duplex. So both the entity or both the communication entities can send the information at a time. So no need to wait for the other person to give the instruction to you, right? So this is what the complete transfer modes, two common transfer modes of the high level data link control, right? So first one is the normal response. The second one was the asynchronous balanced mode. So in the normal response mode, it will be worked, it will work under the configuration of unbalanced. And here in the normal response mode, we will be having the two different type of stations. One is the primary stations and the second one is the secondary stations. And it will be used for both point to point and the multi-point links. And for the point to point links, it will be like this, right? Only the one primary station and only one secondary stations will be there with a dedicated link. But in the multi-point link, there will be the only one primary stations, multiple secondary stations will be there, right? And this will be like a half duplex. And in asynchronous balanced mode, it will work under the configuration of the balanced, means both the stations, the sender or the receiver, both will be sending the commands as well as the response. And it will work under only the P2P link. Right. So now we will see the frames, HDLC frames. So what kind of frames will be there and what is each functions of these frames and format of frames and how the ARQ protocols will get activated in these frames. Right. So these things will be studying here. So these frames will provide the flexibility which are very much necessary in order to support the all the options possible in the modes which I have explained earlier with the different configurations, right? So in the HDLC, there are three different types of frames. There are three types of. So the very first one is the information frame. Information frames. So this in short, we will call it as a I frame frames. And the second one is the supervisory frames. In short, we call S frame. And the last one we call as unnumbered frames, and we in short we call U frames. Right. So the each type of frame serve as an envelope for the transmission of different types of messages. Okay, so the very first one, I frames, right? Yeah. I frames or the information frame. The name itself it will gives the some information about the frame, right? So it has information. So what kind of information? It is the actual data or the user information. It will be there, right? So you can write here. It is used to transport user information or the data along with the control information relating to user data. Right. So in the last class, I have explained the piggybacking, right? where the receiver will be sending the acknowledgement. Along with the acknowledgement, it will be adding its own payload and the whatever the next frame it wants, right? So this kind of sending information we call the control information, right? So the control of the sender will be having the information which has sent by the receiver, right? So for example, the sender is there here. You can think of one sender is there and the another receiver will be there, correct? And the sender will send us some data and receiver will send some other data, right? Acknowledgement. So along with the acknowledgement, payload also will be there. Whatever the information the sender has asked, that information along with the next packet, whatever it wants, that will be there, correct? Along with this, one more very important is the amount of information it can receive, that we call the receiving rate or the buffer storage of the receiver information will be sending to the sender, right? So those things we'll call the piggybacking, right? And this kind of information in general we call the control informations, right? This is the piggybacking. And the second one is the supervisory frames, right? So here supervisory frames, it is used only for transport of control information. So here there will be no user data, nothing, just the control information will be there, right? In terms of the acknowledgement, if you thinking of yesterday's those diagram, these kind of a diagrams, so there the acknowledgement. And very interesting one was the unnumbered frames or the E frames. It is used for management. Used for the system management and information carried by U frames is intended to manage the link itself. So whatever the information the U frame is carrying is only intended to manage the link, whether the link is connected or not, or link is disconnected, right? Or overload onto the link, right? So these kind of information will be uh, given by the U frames, correct? Now we will see the different formats of these frames. First we will see the iframes. So in the iframe, what and all will be there is the first one. Stop there. I'll write here. Yeah. So the flag field will be there. Second one, the address field will be there. I will tell you each and every field in detail. First, we'll see just the format of all the three. So flag, address, right? Then the control will be there. The control information, right? The control information instead of the info. And as it is a information frame, definitely user information should be there. So user info, and in order to see any errors are there and in order to correct those errors, we need a checksum or the CRC, right? So here we will be using this CRC. So for that we have to write here FCS. So FCS is frame check sequence. So which I have already explained in the CRC error detection technique, right? And finally the flag. So this is how the complete format of the frame will be there, correct? So I'll put it in this so that you'll get a little more idea. Good. Yeah, this is the iframe complete, and these are the fields which it contains. Right. Now we'll see the next one that we call the S frame or the supervised frames. So I already mentioned here the supervised frame. It contains the information about the control information, only the control, right? So now we'll see what and all the information will be there. Yeah. So the flag, as usual, should be there, and addresses, source and the destination, and the control information. Of course, it should be there because it is mainly used for transporting the control information, and user information should not be there here. And FCS, of course, we need. So I'm not deleting the FCS, and the end one is the flag, last one. Correct. The third frame is the U frames. And in the U frame, what and all will be there? So as I mentioned here, it is used for the system management, and especially it is used to manage the link between the source and the destination. Or in general, you can say the management of the communication link which exists between the two communicating entities. And flag, of course, should be there, and the address and the control information, and instead of the user information, we will be having the management information, and FCS, and finally the flag. Right? All these frames, we are having few common things here. So at the beginning, at the and at the end, we'll be having the flag, and this flag indicates that that is the starting and the ending of the frame. Right? So let's see one by one these fields explanation fields, right? And the very first field we'll be seeing is the flag one, because that is the first one we are having, and which is present in a both the side, the input as well as the output, means starting and the ending, right? So it is an 8-bit, sorry, 8-bit sequence with bit pattern 0, 1, 1, 1, 1, 1, 1, 0. So 0 followed by 6 ones and end with the 0. So this bit pattern in the field, actually the system has to understand, right? So what kind of a field are the, what kind of a are the starting or the end of the frame, right? So in order to distinguish the starting or the middle of the frame, we have to use a unique sequence of the bit patterns. So here we will be using the bit patterns 0 followed by the 6 ones and the 0. So these 8-bit identifies both beginning and the end of the frame, and it serves very important one, has a synchronization pattern for the receiver. right? So this is about the flag. The second one is the address field. Address. I'll write here only. Address field. So it contains the address of the secondary stations, right? It contains the address of the secondary station, or you can say the receiver address, right? And it is a one or more byte long depending upon the size of the network. So what kind of a or what type of the networks size we are using. So depending on that, the address field uh, bits will be assigned. So this is about the address field. So in general, you can say that it's a physical address of the stations or the receiver or the secondary stations. So the second one is the control information. Information. So it's again a 1 or 2 byte segment of the frame, and this is specially used for the flow and the error control here, right? You can write here, it is a 1 or 2 byte, 2 byte segment of the frame, specially used for flow and error control. So this is about the control field. The fourth one is the information field. Information field. And information field, it contains the actual user data. So that has sent from the above the data link layer is the network layer, right? From the network layer, right? And its length can vary from one network to the another network. So we'll see this one in the when I explain with the example, right? And the fifth one is the FCS field. So this is the frame check sequence. Is the HDLC error detection field, right? So you can, yeah, I'll write here error detection field, right? So see in the control information, I have written the error control, and FCS field, I am saying the error detection field, right? So once the error detection is once we get the information about the error in the frame, then this field will give the uh, information to the control information, and here this using this information it will control the error, means it will be resending the it will be sending the acknowledgement, right? The packet which has got with errors. So that's the meaning. And the flow here I am saying this is for the sending the or the controlling the sending rate of the sender, because the receiver will be sending the information about the receiving rate and the buffer information. So depending on that, the sender will start controlling its sending rate. Correct. So this is the FCS field. So the that's all about these fields, different fields involved in the different frames. Now we will see the exact or what exactly the how exactly it looks when we send the frame, these frames. So the very first one we'll see the iframe, iframes. Means whatever I have explained these fields. So if you add these fields there, so how it will look, right? So I will take the one iframe. So this is what we are having, right? And we know the flag here 0, 6 ones and 0, correct? And here you can write the IP address. So I'll just write the IP address of, just write the IP address. Otherwise, again, it will be right. And this control information, correct? So this control information field, I'll just explain it with a little information, little more information. What kind of a fields will be having the in the control information? So here it is a 8-byte field, 8 bytes field, and the first one it will be having is the 0. This is the 0. I'll tell you what it is, the why the 0 is used to that. And the next one is NF of S, and next one is P slash F, and the next one is the N by N of R. I'll just highlight it and I'll put it in this box. Yeah, it will come fine. So these are the fields we are having in the iframes, especially the control information field. This is exactly, it looks like this, right? And here this 0, right? So this 0 indicates it's a iframe, indicates iframe. So again, we will be having the different, if it is a 10, it will be like a S frame, and we are having the one more called the other different patterns. So that indicates like a 11, it indicates the U frame. Right? So as of now, we'll just see the iframes. So 0 indicates the iframe. So 0 indicates iframe. And this is of the only 1 bit. Is of the only 1 bit. Only 1 bit. And the n of S, instead of that, I'll just show like this. Yeah. N of S. So this is the sequence number of the frame. This indicates the sequence number of frame, and and its length is the 3 bits, correct? And 3 bits. So total number of sequence numbering we can get is 0 to 2 raised to 3 minus 1, right? In general, we can say we'll get 0 to 7 frames, correct? So that is the sequence numbering. And we are having the one more similar kind of thing is the NR. This is the NR. And NR is same, whatever we had here, sequence number of actual frame, here sequence number of acknowledgement frame. Acknowledgement frame, and it also has the 3 bits, and it's ranged from the 0 to 7 acknowledgement frames. So here you can write acknowledgement frames. And the last one, this one, the P/F, right? The P/F means, P means pole, R, F means final. So this has two different things, the pole and the final. And if it is the in this bit, this is a just 5 bit of length, and if it is 0 here, right? If it is 0, then that indicates that the frame is going from primary to secondary. And if it is 1, then the frame is going from secondary to primary. So this is how the complete control information will look like, right? Now we'll see the next frame. We call this S frame. So we'll just see the control field of the all the frames so that you will get the clear idea for the S frame. Just make a highlight. So whatever we have studied in the I frame, so similar kind of a structure will be there here as well, but with little change. So some changes are there. We'll see what are the changes. Right. So this is about the control, so that I can write like this. Yeah. Good. Here, the first one, we will be having the 1 0. So this is the first field, and this indicates the 1 0. If it is there in the frame, that indicates the S frame. Right? Because all the frames are having the starting and ending same bit, and address also same, right? The very next one, we have to see the control information, right? So this is where actually we can differentiate the other frame. That's why here 1 0 1 0 means it's a S frame. Then, so next one will be having the S. I'll tell what it is, and PF is same as it is, and other it is same. So it's good. Yeah. So this 1 0 indicates the correct. Let's make it bold. S frame. Then here S and S. So this is a one code, and I'll just write here S because I need. So S and S. So it has a code, and this code is so 0 0 0. So 0 1 1 0 1 and 1. So this is the pattern. The this second field of the control information is S and S. So 0 0 0 1 1 0 and 1 1. So each of these bits, it gives its own meaning, right? So let's see what it is giving. So the very first one, 0, 0. So 0, 0 indicates the receiver is ready. Receiver ready. It means 0, 0 means receiver is ready. Right? And 0, 1. 0, 1 is reject the frame. Reject. See, orally we can say reject the frame, but the system has to understand, right? So for that, we need to give a one kind of a zeros and ones code. So this is how the system will be taking. 1, 0 means receiver not ready. Receiver not ready. Because there may be some kind of a congestion might be happening, right? So the congestion control mechanism is used. Use the bit is the 1, 0, and the last one 1, 1, 1, 1, 1. It's a selective repeat. Selective repeat frame. So I want a particular frame, and 1, 1 is that it indicates that frame. And what kind of 1, 1? So this information will be there in the NR. And as I said, NR contains the acknowledgement information, right? So here NR, whatever NR and NS, PF we are having the same thing here also we will be having P slash F, pole or final, whether it going from the source to receiver or receiver to source sender, and NR is the acknowledgement frame. So depending on this acknowledgement bit will be varying, right? So this is about the S frames. And similarly, we will be having the iframe as well. So same to same, whatever we had here. So same will be there. Only the uh, control information will be there. The management information will be there extra. So only this will be the different in the S frame, U frame, right? So now I'll just stop here. And we'll again in the next class we'll start from the U frame. So I cannot complete the complete U frame now. So anybody has any kind of a queries, you can ask now.